Let us start solving this system. Your goal is to check to see what is the relation between these three lines. First, convert this into augmented matrix. You have -3 times x to end up with -3 plus 5y. So you have 5 as the second entry on the first row. And finally, the constant term is -22, which is written here. From the second equation, you get the second row of the matrix, which is 3, 4, and 4. From the last equation, you get the third row of this matrix, which is 4, -8, and 32. Remember that your goal is to convert this matrix into the general form, as you can see down here. You need to have pivot 1, and everything below 1 must be 0. Then you have pivot 1, and below 1, you must have 0. This is just in row echelon form, it's not in reduced form. And finally, if you have the general form, your goal is to make this guy equal to 1. What we're going to do, we're going to use elementary row operations. We're going to either interchange two rows, multiply a row by a non-zero constant, or add a multiple of a row to another row. So let us begin. Here we go. Divide the first row by -3. Why is that? Because our very first element here is -3. But take a look at your general form. It must be 1. The best way is to just divide everything by -3. Dividing by -3 gives you 1, -5/3, and 22 divided by 3. So you have to pivot 1. Everything down here must be equal to 0. So you can basically say that, okay, I could go back to the first row and just add it to the second row, which is basically the same thing that we're going to do here. We're going to multiply the first row by -3 and add it to the second row. What is the algebra behind it? Take a look at your algebra. The algebra is -3, 5, -22, added to the second row, 3, 4, and 4, which gives you 0, 9, and -18, which is basically your second row here. Now, you can multiply the first row by -4 and add it to the last row. Why is that? Because you need to have 1, then every element down here must be equal to 0. So far you have 1 and 0, but this 4 needs to disappear. It needs to be 0 as well. So let us multiply the first row by -4 and add it to the last row, which gives you 0, -4/3, and 8 divided by 3. What you can do at this point, you can basically say that, okay, I have 1, 0, and 0. I'm good with the first column. For the second column, the pivot must be 1, but it's 9. So you can divide everything on the second row by 9. You get 0 divided by 9, which is 0, 9 divided by 9, which is 1, -18 divided by 9, which is -2. You basically get 0, 1, and -2. Again, you have 1, and then every element down here is 0. Then you have a 1. You're happy. But down here, you don't have a 0. You see -4/3. What you're going to do, you're going to multiply the first row by 4/3 and add it to the third row. By doing that, the last row becomes 0 row. So this guy, everything here is going to be 0. Now, take this matrix and convert it into a system of linear equations. You have 1x minus 5/3 y equals to 22/3. 0x plus 1y equals to -2, which says that, hey, I have a value for my y, which is -2. Use back substitution to calculate your x using basic algebra. Your x becomes 4. So as you can see, this system, this original system, has a unique solution, and that unique solution is 4 and -2. So the system is consistent.